Welcome back. Now let's do question 4. In 4.1 they say sketched below is the graph of h. We can see that the formula that is given here is for a hyperbola. The asymptote of h intersect at 1 and 2, meaning here our coordinates we have 1 and 2. From the graph of h, write down the values of p and q. So we want p and q. What do we know about hyperbolas? We know that the general equation is given by x plus p plus q. If we have q, that means that our graph has shifted in the y-axis. You can see that this asymptote here is no longer at 0. It has shifted 2 upwards. So in 4.1.1 where it says write down the values of p and q. Q tells us how much our graph has shifted in the y direction, and it has shifted positive 2. Therefore, our Q is equal to 2. Remember also that for a hyperbola, the asymptotes intersect at point negative p and q. So you can tell that your q is 2 because your q gives how much your hyperbola has shifted in the y-axis. And the formula of the asymptote is given by y equal to q. What about p? Now, p that we find here in our formula is that it gives us the shift in the x direction. Now, p will tell us how much we shift in the x direction. We see that our hyperbola has shifted 1 unit to the right. If it is a positive 1, that means that p here is negative because we are going to get x plus p equal to 0. Remember that x plus p equal to 0 is our asymptote. Remember, x plus p must never give us 0 because if the denominator is 0, then this entire fraction will be undefined. So we try to not make x plus p 0. But if it were to be 0, then our x would be equal to minus p, transposing this p to the right. Now it tells us our asymptote, where our graph can approach but it can never reach, because if it ever reaches there, then this denominator will be equal to 0. So p is our vertical asymptote, how our graph has shifted in the x-axis. That means that if it is positive, we take a negative p. So it is negative 1. Now let's see if that's true. Now let's say down here, let's put it here and say x minus 1, since p is minus 1, is equal to 0. And therefore x is equal to 1 when you transpose 1. Therefore you have a positive 1 here. Therefore p is equal to minus 1. Also here, you can see that the coordinates of the point where the asymptotes intersect with each other is given by negative p and q. So if the value is 1, that means that p must have been negative, so that negative multiplied negative gives you a positive 1. So therefore here we have our q and our p. And now that I have that, let me update the formula for h. So now we have 1 over x minus 1, because p is minus 1, plus q, and our q is equal to 2. And that there is our formula for our hyperbola. Now going from there, we have 4.1.2 that says calculate the coordinate of the x-intercept of h. Now to calculate the x-intercept of h, we want the point where our graph here of h cuts the x-axis. And you can see that the y-coordinate is 0 while the x-coordinate is something. So if we make our y 0, then we'll find our x. So we say that for x-intercept, let y be equal to 0. That means that in our function here of h, our h at x will be equal to 0. So we substitute 0 here, equal to 1 over x minus 1 plus 2. Therefore, we solve for x. Transpose 2 into the other side, you have negative 2 equal to 1 over x minus 1. Then I cross multiply, then I will have negative 2x plus 2 equal to 1. Therefore, my x is equal to 1 over 2. So it will cut here at 1 over 2. But they said calculate the coordinates. So you have to give the coordinate of the x-intercept. So the x value is 1 over 2 and the y value is 0 because we let y be 0 to find our x coordinate. For x-intercept, you let y be 0. For y-intercept, you let x be 0. In 4.1.3, they say write down the x coordinate of the x-intercept of g. Now we have a new function here of g where it is given by h into x plus 3. They gave us h at x, g at x, and it is given by h at x plus 3. Now in our original function, it means that instead of just having x, we are now going to have x plus 3. So wherever we see x, we are going to substitute x plus 3. Let's do that. We have x plus 3 equal to 1 over, when we see x, we substitute x plus 3. So we'll have x plus 3, and then we still have our minus 1 plus 2. Therefore, our new function of g, this gives us g at x, which is equal to h plus 3. This is not a division sign. Is equal to 1 over 3 minus 1 x plus 2 plus 2. But the question wants the x coordinate of the x-intercept. Therefore, all we have to do is for x-intercept, let y be 0. Therefore, we're going to let this part be 0. We have equal to 1 over x plus 2. Should always write down that for x-intercept, let y be 0. So negative 1, if you transpose the 1, equal to 1 over x plus 2, negative x, negative 2 equal to 1. Then negative x is equal to 3. So x is equal to 3. Now for 4.1.4, it says the equation of an axis of symmetry of h is y equal to x plus t. Determine the value of t. When you have a hyperbola, especially one where it hasn't moved, the axis of symmetry here will be given by a line that goes here, and that line is equal to y equal to x. Now, if you shift your hyperbola upwards, your line of symmetry will also shift upwards. If we shift it down, it will shift down. Now, if your hyperbola was a negative 1 and they were in here, then the line of symmetry will be given by a line with a negative gradient whereby y is equal to negative x. And it will also shift depending on where your hyperbola shifts. Now, your line of symmetry always passes these two asymptotes. Now you see in the vertical, you have an asymptote here, you have an asymptote here. The line of symmetry will always pass where the asymptotes intersect with each other, which means that in our function here, our line of symmetry will pass here where these two asymptotes intersect with each other at point 1, point 2. Now they say that the function of the asymptote is given by y is equal to x plus t. Now, if we know x and y at that point, which is this point, then we can calculate t. Our y is equal to 2, our x is equal to 1 plus t. Therefore, t is 2 minus 1, our t is 1. What I did here is use the point at the intersection of the asymptote to find my line of symmetry. the line of symmetry will always pass where the asymptotes intersect. With 4.1.5, determine the values of x for which -2 is less or equal to 1 over x minus 1. So they want where -2 is less than 1 over x minus 1. The x values, meaning that we are looking for the domain whereby -2 is less or equal to x minus 1. So what I'm going to do, I'm just gonna move that 2 and leave 0 on this side. So I have 0 is less than 1 over x minus 1. When you move 2 to the other side, it becomes positive. So I added 2 and I added 2 this side. Now, if you look at the new function that we have here, it is the same as our original function, 1 over x minus 1 plus 2, 1 over x minus 1 plus 2. So basically they want all the x values where our function h into x, our function h, our original function is greater than 0. I'm basically looking for this part of the graph because there it is greater than 0. 0 is this line. So I want my x values where my graph is greater than 0. It is greater than 0 from this point, and it's also greater than 0 here because it is above the x-axis. So in the positive y, that's where it is greater or equal to 0. So my x values, it will come all the way from infinity, negative infinity, and stop at 1 over 2 because that's where it intersects with the x. And here it says less or equal to. So I will add my 1 over 2 and make a square bracket because I include that point because it says less or equal to. But also, it will also start from my asymptote here is equal to 1, but it is not included because it is an asymptote. So my function never touches 1. So it will also start from here and go all the way that direction and never pass this asymptote. So I will have 1 until positive infinity.